Hello, in the institute we had a power cut. Okay, that's why I am connecting through my mobiles to have the internet. So that's why it was disturbed. Okay, I don't know whether means I can complete because no power is here in the VNIT Institute. You can see we have, I mean, here it's in the VNIT, so we had power cut. I mean, that's why it was disconnected, but I don't know how much time my laptop it will take. So we should continue. Okay, so you see here, am I audible? Am I audible? Hello? Hello?
Sir, you're audible, sir.
Oh, okay. Then this is fine. Okay, so in BNIT, I don't know whether I can complete the class or not because its power is not here in my office. Okay, so let's see how much time it will take to complete. So first we will go for extension of Newton's Raphson's method. In the previous class, you see I had derived the method for you can see we had derived the method Newton's Raphson's method for solving only two equations in two unknowns. You can see we had the Newton's Raphson's method. You can easily find here. So we had only two equations in two unknowns, which is given in equation here in equation 1. Suppose if you want to develop Newton's Raphson's method for solving the system of n equations in n unknowns. You can see in equations 9, you can see I had mentioned in equation 9 here, this is the system of n equations in n unknowns. So you can see the equations are given in the functions form. So this is your first equations. You can see it is f1. This functions depends upon n variables x1, x2, and xn. This is the first equations. And the second equations I had written in terms of the functional form. This is f2, x1, x2, and xn. And similarly, last equations, that is nth equations, is fn, that depends upon x1, x2, and xn equals to 0. And how we can derive the Newton's Raphson's method for solving the system of n equation in n unknowns. Where is the differences? The differences in the Jacobian matrix, because we had derived the Newton's Raphson's method in standard form and also in the matrix form. So we are extending that idea which we had written for the matrix forms to the n cross n systems. Now, equation 9 you can write in this form. That is the you can see it is a vector form we had written in the following form. And f I had defined. You can see this is a vector that contains the this elements f1, f2, and so on fn. From where you got this? Because you can see here from the expression it is f1, f2, and fn. So I had written in the vector form f1, f2, and fn. So it is transpose. Okay, then x is your unknown vector, so which can be written as x1, x2, and xn. Okay, these are the unknown vector. Now, as you know that to start the Newton's Raphson's method, you require one initial approximations that I had written in vector form x, and 0 subscript means it is the initial approximations. So x1 naught, x2 naught, and xn naught. So be an initial approximations to the solutions of equation 9. Okay, then Newton's Raphson's method for solving the equations 9 is given by this expression. You remember, this is the formula for Newton's Raphson's method if you are extending to the n cross n systems. So same formula. What you had done for the single equation case, xn plus 1 is equals to xn, then it is fn upon fn prime. But when you extend this to the system of two equation case, so you had written it's the same formula, xk plus 1 xk minus jk inverse fxk. But there you had the only the k, that is x, that solutions vector that contains only two unknowns, x1 and x2. Sorry, I had written in terms of x and y. But here unknowns are x1, x2, and xn. So you can write this is the Newton's absorption method formula. And here you remember this jk. Jk is nothing but the Jacobian matrix. So Jacobian of functions of n variables. So how many you have studied in a math 2? So Jacobian of how many variables you have? Functions of, let's say, f1, f2, and n functions you have. So what is the Jacobian? How do you find the Jacobian of the n functions? Here, this is nothing but a matrix. So Jacobian, you can see here, this is a dou by dou x1, dou by dou x2, and dou. I mean, you have to differentiate. I mean, f1 depends upon how many variables? x1, x2, and xn. So you have to make the partial derivative of f1 with respect to x1, then x1, x2, then x3, and so on xn. So you can see in the Jacobian matrix in the first row, you have the partial derivative of f1 with respect to each variables, x1, x2, and xn. Similarly, in the second row, so you have to differentiate the functions f2. So f2 you have to differentiate with respect to each variables. That means x1, then you can go for f2, x2, like that. You know this thing in maths too, how to find the Jacobian of the functions of several variables. So this is the second row contains the partial derivative of f2 with respect to each unknowns. Then if you go for nth row of this means matrix, then you will have to differentiate partially your nth functions with respect to x1, x2, and xn. Okay, this is the Jacobian of functions that f1, f2, and fn. So you had n functions. That's why this matrix has the size n, n cross n. Now jk. So it is written here jk in the formula. It is jk. What does it mean? Jk. What does jk means? Jk means the Jacobian matrix you have to evaluate at the point xk. Each iterations you have to evaluate. X is the unknowns. K stands for is the k iterations. That's why you had here k. K means it is a Jacobian matrix as the kth iteration. If you substitute k equals to 0, that means Jacobian at the initial approximation. J1 means Jacobian at the first iterations, like that. But you remember, if you have a function, we can't go beyond the 3 equations. We will have a maximum 3 equations in 3 unknowns. In the exam and in the assignments, you can find 3 equations and 3 unknowns. We can't ask the questions more than 4 equations case. Okay, 3 equations case. So if you ask Newton's absorption method for solving the system of equations, so we can give a maximum 3 equations in 3 unknowns. Okay. So then you have to find the Jacobian for 3 functions, f1, f2, f3. So you will have the matrix of size 3. Okay. Then it is a Jacobian of the functions f1, f2, fn. And note that the matrix jk inverse is to be evaluated for each iterations. Okay. You have to evaluate in each iterations. Okay. That's why it is subscript is written k. Okay. So now, so I am going to discuss one example. Okay, this example is given also in your assignments problems. You can see, I mean, assignments 2 I will forward to you. Then you can find these problems. So what is given here? So you perform 3 iterations of the Newton's absorption method to solve the system of equations. You can see here you have a system of 2 equations and 2 unknowns. Unknowns are x and y. And you can see this is a nonlinear system of equation because its power is 2 here and q here. So it is a nonlinear system of equations. Okay, so how to find the approximations to the root of this system of equations? And it is given here the system has the solutions near x equals to 1.5 and y equals to 0.5. Why it is given this information? You need to identify what is the initial approximations to the root of this equation. If you get such type of statement in the problems, you can choose these are the initial approximations, okay, to the root of this equation. So take x naught is equals to 1.5 and y naught is equals to 0.5. Then you can start your iterations using these initial approximations. Before that, as you know, in the system of equations case, you need to find the Jacobian matrix. So first you identify what is the functions f and what is the functions g. So I had considered the first expressions as f and second expressions as g. Okay, that's why fxy is equals to this x square plus xy y square minus 7. So you have to take the non-zero term which appears in the right hand side to the left hand side, because you will have the expressions like this: fxy equals to 0. So 0 means you have to make the right hand side 0. That means you have to take the non-zero element which you have in the right hand side to the left hand side to find the fxy. So fxy we get this, and gxy is your second expression, which is this. Now for the Jacobian, you can see Jacobian of two functions f and g can be written as fx, fy, gx, and gy. These are the partial derivative with respect to x and y. And then you can find the partial derivative of f with respect to x. So if this is your fxy, then partial derivative of f with respect to x is 2x plus y, and fy is x plus 2y, and gx is 3x squared, and gy means it's the partial derivative of g with respect to y, because the g expressions is this. So you have to make the partial differentiations with respect to x and y. So after substituting these elements in this expression, so we get the expressions like this. And you know, in the formula, so this is a Newton's Raphson's method for solving the system of two equations in two unknowns. You can see this is the formula. Okay, so JK inverse you can see. As already I mentioned that you have to find the inverse of the Jacobian matrix at each iteration of the Newton's Raphson's method. So since you already obtained the Jacobian matrix, so find the what is the Jacobian inverse, JK inverse. So it is simple. It is 2 cross 2 system. So just you can interchange your principal diagonal element, and you put the minus sign in the non-diagonal elements of the matrix. And here you will have the 1 upon dk. Dk stands for the determinant of this matrix. Okay, so you know these things. It is simple. It's 2 cross 2 systems. Okay, so now what we can do here, so we obtain the determinant of the Jacobian matrix, which is here. This is here determinant of Jacobian matrix. Now you substitute all these informations we have so to this Newton's Raphson's method formula. So you can see here. So in the problem, it is mentioned that you have to perform 3 iterations of the Newton's Raphson's method. So you have to set what is k. K should be 0, 1, and 2. You can see in the last line I had mentioned k equals to 0, 1, 2. You cannot put here dot sign, because in the problem it is given that you have to perform 3 iterations of the method. So you need to put here k equals to 0, 1, 2. So suppose when you substitute k equals to 0 in this formula, then you will get the first approximations. Then that I had done in the next slide. So you can see here. So I had substituted k equals to 0 in the formulas to get the first approximations, which is defined by x1 and y1. Then in the right hand side you have this expressions. So then you substitute all the expressions what you obtained in the previous slides. So x0 and y0, that is your initial vector, then you replace by this 1.5 upon 0.85. So this is your initial approximations, and then you can go for what is the Jacobian matrix at the point initial point, that is your x0 and y0. So which is equals to 1 upon minus 14.25. This is your J0 inverse. So next you go for the vector fx0, y0, and gx0 and y0. So sorry, actually this is your J0 inverse. This is your J0 inverse, because this is your determinant of Jacobian. Okay, so next fx0, y0, and gx0 and y0. So that means you have to find the functions value at the initial point x0 and y0, and you had the 2 functions because system of 2 equations. Then you have g and x0 and y0. So that means you have to evaluate the functions at the point x0 and y0. So after evaluating, we got the value that is minus 3.75, and here this is minus 5.50. Now you see all are the numerical value. Then you simplify these expressions to get the first approximation, so which is 2.2675, then 0.9254. This is your first approximation. Okay, now you can proceed to obtain the next approximation, that is your second approximation. So how you'll get that? So if you substitute k equals to 1 in the formula which I had given in the previous slides, so then you will get the formula for the second approximation. Okay, you can see here, first I had written the formula for the second approximation, x2 and y2. So now what things you have to find out? Then in each iterations you remember only you have to find the inverse of the Jacobian matrix and functions value, because these expressions already you obtained in the previous iterations. You can see here, this is obtained here. So then you substitute over here. Now you have to compute what is the inverse of the Jacobian matrix at the x1 and the y1. That things you have to compute. So I had computed, and this is the matrix which I obtained. And next you find this functions value and functions, that is you have two functions f and g at the previous iteration, that is x1 and y1 and x1 and y1. So then you find the values. So that is I had given here 1.0963, 3.4570. So you multiply this matrix with this vector, so you will get a vector of size 2. Then this is a vector of size 2. Then you can easily subtract these two vectors. Okay, so then you obtain the second approximations, which is this is your x2 and this is your x3, so which is here. And now you can proceed to find your final iterations. So that is your third iterations. So third iterations, how you can obtain, that is your x3 and y3. So x3 and y3, you can see here how you can obtain. If you substitute k equals to 2 in the formula which I had mentioned in the previous slides, that will allow us to find the expressions for x3 and y3. So which is here. And what you need to do here, x2 and y2, you already obtained in the second iterations, and you only need to find the Jacobian inverse at the point x2 and y2, and also f and the functions value, that is f and g at the point x2 and y2. So then you find these two values, and then you multiply, and after multiplying, you simplify to get this value. So this is your third approximations to the root of the equations by Newton's substance method. Okay, so this is your one problem where you had two nonlinear equations with the two unknowns. Okay, so you had x1 and x2. So I will give you one example later. So where you will have three nonlinear equations with the three unknowns. That means you have three equations, and how you can apply Newton's substance method to find the solutions of a such system of equations. That I will discuss later. So first we will discuss today in the system of linear equations case. Okay, so you see here, so you can observe here. So we have expressions like in this form. So now first chapter is over. Solutions of how you can apply all the techniques like a bisections method, regular Polchi method, secant method, generalization method, and the Newton's substance method for finding the solutions of single equations. Single equations, that is your fx is equals to 0. So you can see you had single equation, that means the functions that depends upon only one independent variable, that is your x. And also we have studied how we can apply the Newton's substance method for solving the system of a nonlinear equation that you have studied. Only Newton's substance method that is given in your syllabus. Okay, now we can proceed to find the solutions of a system of linear equations. So this is your next chapter, second chapter, okay, of your syllabus. So let's say if you have system of n equations in any unknowns, that is your x1 and x2 and xn in these forms. You can see this, you know already, these are the system of linear equation you have studied from the matrix theory or linear algebra portions. So a11 x1 plus a12 x2 and a1 and xn is equals to b1. And your second equations, it is a21 x1, a22 x2 plus a21 xn and b2. And if you come to the last equations of the systems, if you have equations in this forms, a1 and an1 x1 plus an2 x2 plus an and xn and bn. So you can see you have here n equations in n unknowns, n unknowns are x1 and x2 and xn, and how you can solve this type of system of equations numerically. Okay, so here I had mentioned that the coefficients aij are known as coefficient and bi's are the known values. If you don't know what is the coefficient matrix and the right hand side vector of the linear system of equation, you can't solve. So you should have the coefficient matrix that associated with these systems as well as means your right hand side vector, then you can find your unknowns x. So it is your general form of the linear system of equations, and we can write this linear system of equation which is given in the standard form in the matrix form. So that I had written in this equation number 2. You can see I had expressed this linear system of equations in the matrix forms, which is defined by equation number 2. Ax equals to b. Okay, so you can see here this is Ax equals to b. And what is A and what is X and what is B? So it is defined here. So A is the coefficient matrix of these systems. What is that contains the elements A11, A12, A1n, that is the first row element, and the second row element A21, A22, A2n, and the nth row of this means matrix are AN1, AN2, and AN. So this is your coefficient matrix that are associated with the system 1. And what is the unknown vector? X. The X contains the unknowns, that is x1, x2, and so on, xn. Okay, so right hand side vector B that contains the elements b1, b2, bn. Okay, so how you can solve this type of equation? So what are the methods available to apply this type of system of equation? So I first give the name of the methods that you will be studying in this syllabus, and then we can discuss one by one. So first is Gauss eliminations method without pivoting. Okay, so that is first one technique, Gauss elimination method without pivoting. You can see I had mentioned without pivoting. And another technique is called Gauss elimination method with pivoting. I will discuss what does without pivoting and with pivoting means. When I will come to this method for giving the detailed explanations, then I will let you know means why pivoting is required for one case, and in other case why pivoting is not required. So okay, this thing we will discuss when I will come to the discussions of the descriptions of the method. So these are the two techniques. Then we will have one more technique that is called LU decompositions method. Then you will have Cholesky method. So these are the four techniques. These are direct method. Direct method means already I told you that direct method provides the exact solutions in a finite number of steps, exact values of the solutions. But in the iterative method, this provides the sequence of approximation. You start with some initial approximation, then you generate the sequence of approximations like x1, x2, so on, xn. And in the limiting case, that means when you take the limit n tends to infinity to the nth approximation xn, then that will converge to the exact solution of the problem. So that is your iterative method. So here I had classified your direct methods and the iterative methods. So iterative methods are this Gauss-Jacobi iteration method and Gauss-Seidel iteration method. So you will study these two iterative methods, how you can apply such techniques to find the solutions of the linear system of equations. And these are the direct methods: Gauss elimination method, LU decomposition method, and Cholesky method. So we will discuss one by one techniques. So how we can obtain how you can solve the system of equations. Now, first we will discuss about what is Gauss elimination method. You can see here Gauss elimination method. First, what I have done here to analyze this, what is the basic idea behind this method. I consider here the system of three equations in three unknowns. You can see in equation number 3, I had given the system of three equations in three unknowns. Your unknowns are x1, x2, and x3. Okay, so and the coefficient matrix of the systems is A. Okay, so the coefficient matrix in your system is your A. That is Ax equals to B, and A is the coefficient matrix of size 3. You can see this is a matrix of size 3, and the elements of this matrices are A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. What you had written, I did not understand. What you had written? We have already studied this last time. You could go a bit faster. No, you did not study this. What you had studied this? You did not study these things. This method you did not study. Gauss elimination method without pivoting and with pivoting. This method you have not studied, and you will get the questions in the exam. Okay, so I don't know. So you are saying that maybe it's with pivoting we studied. Okay, but you will be asked the questions in the exam. So this things is given in your syllabus. I can't go, means if you know that is fine, but maybe other students, they don't know. It is my principle that I will study. I will teach you in details. I cannot go first. Okay. So in matrix forms, so we can write, it is given in your syllabus. I cannot skip this. Okay, so in matrix forms, we can write this. So this is your A, and this is X, and this is your vector B. And then what is the idea? So what you have to do here, so you have to transform the system of equations in the upper triangular systems. So how you can transform the original systems to the upper triangular systems? So this is the idea that you have to apply elementary row operations. So you know elementary row operations, how you have studied from matrix theory. So that was in maths too. So you know these things. So I am applying elementary row operations to convert the arithmetic matrix that is given in this forms, that is the combination of the coefficient matrix and B, into the upper triangular systems. And then in the step 1, we have what we have done. We had eliminated x1 from second and the third equations by elementary row operations. Okay, so how do you do that? So R2, you see I had used this elementary row operations, R2 equals to R2. Then I had taken this multiplier, that A21 upon A11, I had multiplied with R1. Okay, so this is your first elementary row operation you had applied to row number 2. So A matrix, I had written it's the row 1, then row 2, and the row 3. Okay, so R1, R2, and R3. Then this is here, you can see here, this is the R1 element, this is R2, and this is your R3. Okay, then R3 is equals to, then this is the elementary row operation I had applied, R3 minus A31 upon A11, then into R1. Okay, so then after applying this elementary row operations, the main idea is to eliminate, okay, x1 from the second and the third equations of these systems. So then I got here 0, 0, and then the resulting matrix will be in this form, which is given here. Okay, this is your resulting matrix. And the right hand side vector will be changed also, because you had applied elementary row operations. Row 2 and R3 elements should be changed, because you can see this 1 means this is the original elements. It is a subscript which I had written here. That means it is nothing changed. This is same as the original element. That means B1 is equals to here B1 superscript 1 means, what does it means? B1 superscript 1 means this is your B1, original element B1. But the second row, third row element changed, because you had applied elementary row operations to the second row and third row of this systems. So that's why second row, third row elements are changed. Okay, so now you can go for the next steps, because you want to convert into the upper triangular systems. So still it is not upper triangular systems. This is not a upper triangular system. So you have to go for another iteration. So another eliminations you have to use here to convert the upper triangular system. So you can see what I had done here. I had applied elementary row operations to eliminate x2 from the third equations of the systems. Okay, that is your Ax equals to B. Okay, so after applying elementary row operations to the third equations, then your resulting expressions where the coefficient matrix takes these forms. Now you can see here, this is your upper triangular systems. Okay, this is your upper triangular systems, and it is your right hand side vector. Now we finally obtain a system which is in the upper triangular form. Then you can find now what is the solutions to these equations. The system is an upper triangular system which can be solved by back substitution. The back substitution you can apply to get the values for x3, then x2, then x1. Okay, so then you can find this. And the elements which are sitting in the diagonal positions are called the pivot elements. Okay, these pivot elements are non-zero. Okay, so if the pivot elements are 0, then you can apply the pivoting strategy. Okay, if the pivoting elements are 0 and in the elements so which are very small, that means you have to multiply the large number to eliminate that variables from that equation. So in that case, you need to apply the pivoting strategy. So now Gauss elimination method with pivoting. So in the why you need the pivoting that I had explained to you in the eliminations process, because when you apply elementary row operation, you are eliminating variables. So if any of the pivot elements, that is your diagonal elements, vanishes, that means it's a 0 or becomes very small. If these pivot elements are very small compared to the other elements in that column, and then we can attempt to rearrange the remaining rows so as to obtain a non-vanishing pivot elements or to avoid the multiplications by a large number, because you can see here you are multiplying. This is a multiplier. Okay, suppose if you have very small element in that sitting in the pivot positions, and this multiplier so is very large. So in order to avoid that, you need to rearrange the rows, so which is given in your matrix. Okay, so this strategy is called your pivoting. So why pivoting is required? You should write this. Okay, why pivoting is required? Okay, so these things I had mentioned to understand. Then you can go for next slides. So where we have the how we can solve the problems. So that is with a pivoting strategy. Okay, you can see here. I had considered a system of 4 equations in 4 unknowns. Okay. So in the step 1, what we have to do that I had mentioned here, in the first stage of the elimination, you have to search the first column. In the first column, the first column is search for the largest element in magnitude. Okay. Suppose if you ask the derivations, you describe the Gauss elimination method with pivoting strategy, you have to write like that. Maybe that student, I don't know who has commented that, that maybe he has known the little things and he is saying that you go a little bit faster. This is not you don't know what what should be taught and what I should discuss with the student who while you are giving the such statement. You are not asking and you are saying that you go a little bit and you don't know how to write your scientific sentence in the exam also. When I will get the exam paper, you will write the sentence that is not meaningful, and you are saying that you are giving the advice that you go a little bit faster. And when I ask the questions and you derive the Gauss elimination method with the pivoting, what you will write on that? I know I had such experience without thinking a lot about how to construct a scientific sentence in the exam paper. So because some students don't understand what is going inside the systems, so they write some different things, and that will not be point to the correct solutions to the appropriate problems, and here teacher cannot easily understand. You see, and he is suggesting that you skip. I studied. What you studied? And then you explain to me, you have studied these things. What I am going to show here, I already given the 3 slides. And you don't really be over smart. Okay, so in step 1, what I had done here, so in the first stage of the elimination, the first column is a search for the largest element in magnitude. You have to write such thing, then you will get the 5 marks. You will, if you write this just the means elements, we can't give the means the marks to you. What you are doing, then you have to write means the in the full line things. I mean, you have to provide the full details, your explanation, so that your teacher can understand. Just if you write in the first step, we get this metric. In the second step, we get this. So that means you had to remember this element and you are writing. But how you are getting this thing, you should explain them. So in the first stage of elimination, the first column is a search for the largest element in magnitude, and brought the first pivot by interchanging the first equations with the equations having the largest element in magnitude. Okay. So first you understand what it is written here. So in the first stage, what you have to do, you search the largest element in magnitude. Okay. So if it is minus, then you have to take the mods to get the means the plus. Okay. So you have to compare the which element is the largest one. Suppose your largest element is sitting in the row form R4. You can see I am demonstrating this by taking a means the example where the matrix has a size 4 cross 4. This is a 4 cross 4 matrix. Okay, so this is the first row element, and this is the second row element, and this is the third row element, this is the fourth row element. Okay, now I am searching the what is the largest element in magnitude among these elements. So let's say the largest, because these are the numerical, these are not the numerical values. We assume that the largest element sitting in the R4, R means row 4 positions. Okay, R4, that means it is a row number 4. That's why in the outside of this matrix I had written this is R1, this is R2 and R3 and R4. This represents row 1, row 2 and row 3 and row 4. Okay, so let's say the largest element is in A41. Where it is located? It is located in the R4 positions. And that's why I had written here. Let the largest element in magnitude of the first column is A41. Okay, and it lies where it lies. So it lies in the row number 4. So we interchange row 4 with the row 1. Okay, to get the first pivot element, because first pivot element should be placed at the 1 positions. So you need to interchange the row 4 with the row 1. So because you can ask me, why did you did not change R4 with the R2 or R3? Because to get the first pivot element, in principle, the first pivot element should be placed at the 1 positions. 1 positions is located in the row number 1. That is the first row. So you need to interchange row 4 with the row 1 elements. So after doing this, so you can see this is the interchange notation. So this apply elementary row operations to eliminate x1. Once you interchange the elements, then you can proceed to apply elementary row operations. Okay, to eliminate x1 from the second, third, and fourth rows of the resulting systems. Okay, resulting system means the original system is changed. Why original system is changed? Because you had interchanged the rows. So then you get the new system. In the new systems, you have to apply elementary row operations to make this element 0, this element A21, A31, and A41 element 0. It is not straightforward like without pivoting strategy. So you have to apply the suitable elementary row operations to make the element 0, 0, 0. So you see here, this element is this matrix is not an upper triangular matrix. So what you have to do here? So you have to search in the second step, you have to search what is the largest element in magnitude in the second column. But you have to leave this first element. Okay, when you search what is the largest element in magnitude in the second columns, so what you have to do, you skip. I mean, you will not include the first element of this means the columns while searching the largest element. So that's why I had clearly written here. In the second elimination stage, the second column is searched for the largest element in magnitude. So among the 3 elements, you see, because it's a 4 cross 4 matrix, you should have the 4 elements in the second column. But why you are searching 3 elements? Because you are skipping, you are not considering this first element while searching the largest element, because you see your pivot element is sitting at the 2 positions. Okay, it is 2 positions your pivot element is sitting. So that's why you have to skip the element above the pivot positions. Okay, so this is the idea. So that you have to skip your elements which are sitting above the pivot positions. Okay, so that's why you don't need to consider such element in the when searching the largest element in magnitude. Okay, so then leaving I had clearly written here, leaving the first elements A1 to 1. Okay, A1 to 1, you had not consider while searching the largest element, and this element is brought as the second pivot. In the first stage, you got the first pivot A11, and that is your 1, and this is your first stage. In the second stage, you find out what is the second pivot, that is A2 to 2. Okay, so A2 to 2, and because this is a 4 cross 4 matrix, so you will have third pivot also A33, and also last pivot element A444. Because it's a 4 cross 4 matrix, so you will have the 4 non-diagonal entries in the diagonal element, 4 non-zero entries in the diagonal positions. Okay, that's why you are applying the pivoting strategy to get the non-zero element in the diagonal elements. That are your pivot elements. Okay, now we can proceed to obtain the upper triangular matrix. So let's say the largest element in magnitude is A322. This is our assumptions. Okay, let us assume that the largest element in second row element is A322. Okay, 2. You can see here it is written as A32, and it lies in the third row, because you can see here elements is first element is this represents for the row number, second element represents column number. So that's why from this A32 we can understand that this element lies in the third row. So interchange R3, the elements are sitting in the R3 positions with the elements those who are sitting in the R2 positions, and to get the second pivot element A22. Okay, so now you see A22 originally you had in the matrix, so that you obtained after the first stage of the eliminations. Then A32, this is your largest element. Then A32 element will come to the second pivoting positions element. Okay, then apply elementary row operations to eliminate the x2 from the third and fourth row equations resulting in these systems. Okay, this system is given here. You can see here in the pivoting strategy, first you have to search the element which you want the largest element. Then you have to interchange the elements which are sitting in the pivot positions and the largest row, largest elements, and then you have to apply, after interchanging, you have to apply elementary row operations to convert the elements that is 0, that elements are sitting below the pivot position. Okay, now you see these elements are the pivot below the pivot elements. Okay, so this is your pivot elements, and below this pivot element, so you have to make it 0. Okay, but you don't need to make it 0 the elements which are sitting above the pivot elements, so above the pivot position. So you had to apply elementary row operations to convert this and this elements 0, because you can see here in the second stage these elements are not 0, this and this are not 0. Okay, so you had applied after interchanging rows, then you had applied, okay, to make the elements 0. Now you see still this systems is not a upper triangular systems. So what you have to do? Again, you have to go for the third column. So continuing this process, we can obtain the following upper triangular systems. Okay, in the third column, you can search what is the largest element in magnitude. but you have to skip the first two elements because this is your three positions are three positions are pivot positions. So above you have the two elements. This and these are the two elements that sitting above the three positions. So you don't need to search what is the largest element among these four elements. So you have to first skip these two elements. Then you have to search what is the largest elements among these two elements. Suppose these are the largest elements, then you interchange these elements with this element. So after interchanging, then what you can do? So you can apply your the elementary row operations to make the elements zero. Those elements are sitting below the pivot elements to convert it zero. Now you see I had converted, so I got zero elements. So now if you see this matrix, this is an upper triangular systems. Okay, this is an upper triangular system. Now you can solve this upper triangular systems by back substitution method for x4, x3, x2, and x1. When you apply back substitution method, you will get the last unknowns, that is x4, then you come to the x3, then x2, then x1. So this is here the the pivoting strategy. So you see, as I already told you that derivation we will ask in the exam. So you cannot just skip. I mean the derivation part from the beginning. When I started this course, so far I had taken 8 classes. So always I am saying that derivation we may ask in the examinations. Okay. So you have to study the derivation part. Okay. So this example I will discuss in the next class because we have only 5 minutes time. I cannot complete this today. So if you have questions, then you can ask me. If you have any questions, then you can ask me. So I had discussed also the 7. I had completed 7 previously. So if you have any questions also relating to that previous lecture, then you can also ask. It is not a problem because you get the PDF files. So maybe you had some things to identify. So you did not read properly the sentence which I had written, but you can ask such things also. It is not like that today's things you will ask, but the previous things you can ask me.
format